Thank you. 1, 2, testing. Yeah, it works. Nice. So, morning, everyone. It's an honor to be here today. And I hope that whatever I'm going to share with you is going to be of value and is going to poke you. So, my objective today is to poke you, right? The idea is we want to think differently. We want to move away from being the product to being part of the solution, right? To being the custodians of the rails of the technological economics. So basically, my name is Edzai Zvobwo, and like Khalil said, born and bred in Zimbabwe, but I'm based here in Johannesburg, and I'm the founder of a company called Acalytica. So now, the essence of what I'm going to be talking about is about using mathematics for disruption. But the idea is that I'm using mathematics as a vehicle to communicate because I studied mathematics. So instead of mathematics, replace it with whatever it is that you know. So if you're a dancer, say dancing for what? For disruption. So I use mathematics to communicate. But I've realized that because mathematics has been presented to us in a very abstract, very unreal life-like, literally, if that word exists, right? So we've been presented with this subject as this dogmatic subject where if you break the rules, you're done for. There is no room for creativity. There is no room for imagination. You have to follow the rules. 1 + 1 is 2, right? So I'm here to say you can be as creative as possible. And mathematics is at the center of AI. Mathematics is at the center of machine learning. And it's due to the creativity of a lot of people that have come before us that we find ourselves where we are. It's because some people somewhere made a choice and we find ourselves here. If different choices had been made, maybe the type of AI that would be leading right now would have been different, right? So you find that for LLMs to be where they are, it's because Sam Altman saw that paper in 2017 by Google that was entitled, "Attention is All You Need," right? And because he was coming from a VC perspective, he managed to raise lots of funds. And he managed to build product, right? And we find ourselves here because VCs and entrepreneurs coming from a VC world managed to conquer AI. Why? Because there are so many types of AI, right? And the one that took center stage is LLMs because all the money was poured towards LLMs. You have voices of reason, like Judea Pearl, who wrote the Book of Why. You should read that book, The Book of Why. Judea Pearl talks about causality, causal AI, saying that if you understand the underlying structure of data, of how data is generated, you can actually use less power. You can use less compute. You don't need as much data, right? But that school of thought was overcome because it was difficult to do. To prove causality is difficult, but it gives AI understanding. So it means that we chose the path of least resistance, the path that was fundable. And you'll find that technologically, from way back, we've always adopted technologies that are easy to implement, that are easy to scale, the school of thought that is dominant is the one that takes over. As an example, if you look at the fight between Tesla and Thomas Edison had VCs behind him, right? If Tesla hadn't fought, Right now, we'd still be using DC, and there wouldn't be any AC, right? Alternate current. So those fights have always been there at any given stage. So it's important for us to realize that whatever technology is current, it doesn't mean that it's there because it was inevitable. It's there because there was a choice made. So the question is, as Africans, can we make a choice to create technologies that serve us? To create technologies that are optimal for our pockets, that are optimal for our environment, that are optimal for our culture, our aspirations, our everything. Because right now, just like the previous technological revolutions, we are the product or we are mere consumers. So how can we change that? Then I said, no. Mathematics is universal. The mathematics they are using at OpenAI is the same mathematics I learned in Zimbabwe, is the same mathematics that is being taught in Johannesburg. So how can we use this universal language and other universal tools to be able to create things that serve us? Okay, so that is the essence of my talk. Right. So what if Africa's competitive advantage in AI isn't infrastructure catch-up? I left the only, right? Because definitely we need to catch up on infrastructure. So what if Africa's competitive advantage in AI isn't infrastructure only, but maybe mathematical sovereignty? Maybe we need to disrupt mathematics even itself and come up with our own mathematics that serves us, right? It's not written in stone. I thought when I was taught mathematics, I thought mathematical rules were like this, and I couldn't change them. But I've realized that they can be changed. Did you know that? They can be changed. So I'll show you how. But in this book, The Mathematics of Disruption, I have 4 characters. I wrote this book in such a way that anyone can read it. It's a story. You don't need to be mathematical to read this book. So there's Tandy, who is asking questions. Questioning. That's a very important tool that we need. I know in our cultures, like in my culture in Zim Shona, you can't tell an elder that they are lying. You can't question what elders say, right? So it means that we take those cultural norms and bring them into the corporate world, bring them into academia, but it constricts and limits our growth because we're not asking fundamental questions. If the ancestors said 1 plus 2 plus 1 is 3, and you know better, then why should you still continue saying 1 plus 1 is equal to 3? Question it. So that's the role of Tandy in the book, questioning. Then we've got Sipho. Sipho, who studied, at UCT, not here. Right. And he's in corporate. And he's deploying machine learning models. He's working, but now he has been so disheartened that he is very pragmatic and doesn't want to risk it, doesn't want to think away from the norm, just like our corporates in South Africa. Do you know that in corporate South Africa, R&D is a swear word? Did you know that? R&D is a swear word. They don't want to hear about it. They'll tell you straight up, dude, I am measured on a quarterly basis. I will get something that is already done, and I'll run with it. Therefore, I would rather be a reseller or distributor of a product from Germany or from the US, Tabo's algorithm, whatever, it's unproven. And who is Tabo anyway? Right? So unfortunately, that is the dominant thinking in our corporate boardrooms. They don't have time for us. So how can we circumvent that? That is something we need to think about as us like this. And then there's Professor Kumalo. Professor Kumalo is the mentor who is just helping Sipho and Tandy understand the landscape of mathematics for machine learning and AI, right? He's just answering the questions, because don't forget, Tandy is asking lots of questions, right? Then we have the machine. The machine is also clarifying to say, okay, you know what? Sometimes you prompt me 10 times with the same prompt, but I give you 10 different answers. In my world, I am consistent. In your world, I'm not consistent. To the Christians, you'll know there's this, I don't know what the verse says exactly, but it says something like, your time is not my time. I think that was the Lord speaking, right? So same thing, the machine's consistency is not our consistency. Why? Because of the underlying logic that is governing the machine, right? So in the book, like I told you, we'll be walking from one scene to the other, and we'll be listening to Tandy, Sipho, and Professor talking about AI. She'll be asking questions, Professor will be responding, and obviously Sipho, being the skeptic, will be throwing some sand into the conversation like that, right? So we cover things like floating point fragility, right? Floating point fragility. Who knows that computer scientists, for expedience purposes, broke what are known as the axioms of mathematics. Who knows about the axioms of mathematics? Anyone? The axioms of arithmetic, where, for example, you know that 1 plus 1, right, in brackets, plus 1 outside the brackets will give you what? 3, right? And then if you move the brackets such that the first one is outside and the other 2 are inside, you still get what? 3. But then the computer scientists said, no, this is messing us up. They changed it. So they broke the fundamental rules of mathematics for experience to make sure that algorithms are efficient, right? So that means that if you have the confidence, you can actually break mathematics as long as 2 minutes left. Yo! Oh! Okay, right. Okay, so basically this is what I was talking about, right? So we're saying that we have to have the confidence to break mathematics, because mathematics, just like any other subject, right, is not written in stone. So the poke that I'm poking you today is that be courageous. Be courageous to innovate. Be courageous to actually face the norm and question it. Okay, so you find, by the way, this presentation is available. If you just Google mathematics of disruption, you'll see a page on Acalytica. You'll be able to download this presentation. It's already there. So, right, I'm having to run. Right, so you find that in 1985, computer scientists actually changed the mathematics like we saw there. And then in 2017, like I told you, attention is all you need. People came up with the transformer model, right? And OpenAI was the first to adopt it and bring it to market. But these were choices that were made, and we can also make choices depending on what? On what we have. Okay, then, so there are many innovations that I talk about. For example, the most dominant optimization algorithm is gradient descent in machine learning, where gradient descent is almost like you're blindfolded, and then you're moving every step. It's like a stepwise optimization process. But now, it's expensive when it comes to compute. So why can't we create another system where instead of one step, let's take double steps, let's jump, an African one, right? Like the Maasais in Kenya, they can jump as high as possible, right? So why can't we do that? Right, and then obviously, correlation versus causality. Our LLMs don't understand anything. They are probability and statistical machines, so they don't understand the data generating process. So that means that they cannot understand what they're doing. So please don't delegate thinking to LLMs until they know that A causes B. They are dumb, right? But they are good at what? Pattern matching, right? At scale. Okay, so I will skip a lot of things. And yeah, the last thing is, where is the Ubuntu in that AI? How do we infuse our culture within that AI? Okay, I don't have time. So thank you very much.
Thank you so much, Edzai. I'm really sorry.
I'm a pastor. I'm used to 1 hour, 3 hours. Sorry.
And I would definitely listen to you for 3 hours, but unfortunately we have the schedule to follow. I see a lot of questions. So also, guys, you can find the presentation online at Acalytica.
Just Google mathematics for disruption, or at Acalytica, you'll find it there. Yeah.
So we have the first question.
Oh, actually, I just wanted to ask where the presentation is.
Oh, sure. Thank you.
We have a second question here.
Okay, so I wanted to talk on the choice thing. I hope I can be as brief as possible, because it sounds nice theoretically until you actually do try to disrupt. I am doing a master's in mathematical ontology, trying to use math to predict the decisions that people make to survive their worst political situations. So if you could think of it as game theory, nobody wants to supervise that. The game theorists are saying it's too political. The politics people are saying, but why math? And your presentation answers that, because we can then do sort of like causational relationships. There's a lot you could do with math. So how do you break through into getting people to not see you as crazy, but as someone who's actually doing something that's worthwhile?
You know, like we have so many risk-averse lecturers and teachers. So I've learned to search for where my tribe is, whether they're in the US, Russia, or wherever. Like right now, the Turing Award winner, Judy Appel, that I'm talking about, we correspond about causality. Like I've realized that there are not enough people that are talking about what I'm talking about, but he talks about. So don't limit yourself to local supervisors.
Can I go? Okay. Thank you very much for your presentation, great presentation. And I'm actually glad that you point out that when you talk about AI, you talk about mathematics and algorithm. And you did talk about the infrastructure gap on the African continent and how can we create the AI that works for Africa. And so I think that brings a key, how will I say, continental or country level initiative or vision in terms of how the various stakeholders will work together on finding specific solutions to African challenges. We talk about LLMs, but we're also talking about how we use AI at the edge, for example, small language models, etc.
Yes.
How are you, or are you engaging with various stakeholders, let's say government, let's say universities, let's say the private sector, whereby there is this R&D that needs to take place to strategically enable those who work in that sector to provide solutions?
Yes,
Thank you.
Thank you very much. So on my side, I sit on the expert panel for emerging technologies for African Union, out of NEPAD to be specific. And we've written a couple of papers that were advising the 54 states in Africa around how to adopt AI, 3D printing, 5G, and all that. So we are trying. And also, there's a new commissioner at the AU who is in charge of infrastructure, and she's very much looking at AI infrastructure as well. But it is our duty, all of us, to spread the gospel, because our governments need a bit of knocking on the head for them to actually understand what's happening.
We have the last one here.
Hi. So actually, it was not a question, it was more of me to say that I pretty much like your presentation, probably the best one that I've enjoyed so far. And it makes sense because you said something that resonates with me. I think we are in a lot of applications today. Like we want to take maybe a model that was developed somewhere and then apply it and make applications. But like the lady was saying, we need to be crazy enough to think about fundamental research. Like you talked about the gradient descent, you talked about many optimization techniques. We need to think out outside of the box and like look at things that can be more relevant to our, I would say, our context. So, I don't know, maybe you have enough voice and power to actually raise the awareness, because I think, and I believe of an Africa where we own our technologies. Like if Google, I was talking with someone yesterday, I was like, if Google decides like, today I'm not providing you Google Translate anymore, we can't do anything, right? But we have the minds, we have everything that we need, we just need to be courageous enough and like pursue research instead of imminent like results.
Sure. No, thank you very much. So I'll give you one practical example quickly of being courageous and being confident in what you're trying to do. So Elon Musk, he realized that there's a lot of energy being used in data centers, big data sets and stuff like that. You know what he simply did? And you can Google it. So for Tesla robots now, he has made a trade-off between accuracy and efficiency. So he has removed the commas. You remember that floating point system I was talking about? He has removed them. He's using integers, right? Integers, whole numbers only, right? Positive whole numbers only. And that means that he's using less energy, his robots are faster, but at the expense of what? Accuracy. Thank you.
Thank you. Thank you very much. I will go as more concrete and say not Google will stop supplying, but tariffs. So yeah, thank you very much. Edzai is also sitting right here outside if you want to buy the book. And we have a best presentation, so I hope that we can beat it in our next presentation. Good luck, Alex.